inventions and innovations. And now it's available for everyone.
Everybody from the front to the back now.
Bring it back to the
Switch it. Yeah. Make the building collapse, drop the bomb, bomb, bomb. Bring it like that. Bring it like that.
Hello, everybody. Welcome to class today. This is the third week of doing live stream classes here in the virtualization class. And this week I don't really have very many slides, so we're probably not going to take very long with this. Got a few objectives for us to have a look at today. So before we get into the content today, we'll have a quick look at our objectives as per usual. What we're going to do today is we're going to describe what comprises a virtual machine. So over the last couple of weeks, we've been talking about, what virtualization is and kind of how we get into all that. Now we're going to actually talk about what a virtual machine is a little bit more. We're going to talk about how resources appear in a virtual machine. We're going to look at how requests move from a virtual machine through the hypervisor and then back again. And then we're going to mention briefly the Open Virtualization Format, or OVF, just kind of in passing as we get to that at the end of our time today. So let's get to it. So when we're talking about what a virtual machine is, a virtual machine is just a set of data files. Really, when you're thinking about it, a virtual machine is really nothing more than a set of files that describes and comprises some sort of, virtual server or virtual device. The main files that make up a VM are the configuration file and the virtual disk files. So the configuration file describes the resources that the VM can utilize. So it enumerates the virtual hardware that makes up that particular virtual machine. So in that sort of way, you can kind of think of the virtual machine as like an empty server or an empty computer that you just built. The configuration file then lists the hardware devices that would be in the device. The CPU, the memory, the storage, the networking, so on and so forth. And we're going to talk about those components being virtualized in a little bit. So it's basically, when we make this virtual machine, it's essentially just a block of files. And with that block of files, we get this logical host that's just like a brand new computer or a brand new server that just rolled off the factory line. So it's the instantiation of a container that runs our application. Instantiation being the instance or, that particular machine that's running our application, whatever that may be, whether it's an operating system, whether it's a virtual application, or what have you. So we're defining a virtual machine in that sort of way. So virtual machines use virtual hardware, and we've mentioned this before. From the perspective of the virtual machine, it's real. From the perspective of the virtual machine, it's real. Virtual machines don't know they're virtual machines. From their own point of view. It's kind of like, like when you think about like the whole evil twin thing, like from like movies and stuff, like the evil twin never knows that he's the evil twin, he's just a guy, and, or whatever, As far as the virtual machine is concerned, it's a real machine. So it's looking at these virtual hardware resources that we've talked about in the past as if they're real hardware resources, but they're not real hardware resources. We've mentioned this in the last couple of weeks, that, virtualized hardware resources are just approximations of what the machine actually has. And we'll talk about how these resources are virtualized in just a moment, because different resources are virtualized differently. But from the virtual machine's perspective, it has to see it as it being real, because that gets at Popek and Goldberg's fidelity property, which is what we talked about in the first live stream. We talked about the three properties of virtualization according to Popek and Goldberg. Fidelity being one of the major ones there. We want it to run the same as if it would on an equivalent machine. That's the fidelity issue. So if we were meeting that fidelity property that was set forth by Popek and Goldberg, ideally the VM would not think anything different of the virtualized hardware. And so virtualization approaches each resource differently. And what we're going to do now is we're going to have a look at a few of the different virtual resources that are virtualized during the virtualization process. We're going to have a look at virtual CPUs, virtual memory, virtual networking, and virtual storage. And we'll talk just a moment about how each of these resources are virtualized, or what happens when they're virtualized. So virtual CPUs, also called vCPUs, are essentially scheduled slices on physical CPUs. So you can kind of think about it as being like, okay, I got a 4-core processor. One of these cores of this 4-core processor I can virtualize and use as a single-core processor in my virtual machine. So we can schedule this processor for dedicated processing time. So we can schedule parts of our processor for dedicated processing time while our hypervisor is running a certain virtual machine. We don't have a lot of ability to manage our virtual CPUs in our virtual machines. We can adjust the amount of CPUs that we can give it. If we have an 8-core CPU, we can adjust the amount of cores that we can dedicate to this particular virtual machine. Whether we want to, dedicate all 8, 4, whatever. But outside of that, we really don't have a whole lot of ability to manage our processing power when making virtual machines, which is something that you've probably noticed as you've been working to create some virtual machines yourselves. So that's more or less virtual CPUs in a nutshell. It is important to remember that usually the host has more CPUs available than any one VM. And that the hypervisor is scheduling time on those processors on behalf of the VMs rather than the VM actually having a dedicated CPU. So that's more or less how that works. So we're all clear there. I just wanted to make sure that I had that note kind of clear. Virtual memory. So a virtual machine's memory is mapped to physical memory, but it's managed by the hypervisor. So a virtual machine can see, or can only see, and utilize the amount of memory it has been allocated. So memory is probably the simplest to understand in the virtual environment. So just like in your regular physical machine, having enough memory resources in a virtual machine is basically the difference between success and failure when you're evaluating an application's performance. When a virtual machine requires more memory, unlike a physical machine, you can reconfigure that virtual machine as long as the host machine has the memory available, which is a good thing. Hi, Vince. So as long as the host machine has more memory available, you can reconfigure that virtual machine to get more memory if your application needs more memory, which is something that's a little better than your physical machine, oftentimes. And sometimes you can, depending on the process or the hypervisor or the operating system, you can actually even do that without a reboot, which is pretty cool. And we'll talk more, and we'll probably talk more about memory management a little later on down the line. But like CPUs, you can really only adjust the allocated amount of memory, so you can just give it more or less. And there are a lot of memory optimization features available, but we'll probably talk about some of those down the line. So as long as you have host memory, you can allocate it to it. So that's the gist of that. So virtual networking. Virtual networking is fairly interesting. So this is how virtual machines communicate with the outside world. And as we kind of looked at in the last module, the module that you guys completed recently, there are some different ways that we can set up networking within a virtual machine. One that allows the virtual machine to communicate with the internet, and some that only allow VMs to communicate with other VMs without going out on a physical network. If you wanted to do that, what you want to do is you want to put your VMs in something called host-only networking mode. And this can kind of let you create a kind of virtual LAN of your virtual machines, or a LAN between your host machine and your virtual machine. So it's not connecting out to a physical network, it's only between your virtual machines and your host. So it's pretty good for security as far as all that goes. You don't want, because while that virtual machine is isolated, once you're going out onto a network, things that go out onto a network can affect the broader network. So to keep things isolated, you would want to keep it limited as far as all that goes. But this is one of the areas that's most likely to be misconfigured, because as a lot of you have taken like Net 125 and all these other networking courses kind of realize, networking devices can be fairly difficult, and it gets even more difficult when we're working with virtual machines. So essentially what we're working with, like the hypervisor supports the creation of the virtual network, and that connects the virtual NICs to a network that's composed of virtual switches. And it's this virtual network that the physical NIC actually connects to. So you're getting virtual NICs and virtual switches and connected to the physical NICs, and as those of you who have taken networking classes can probably vouch for, when the more devices that you throw on the network, the more things that need to be configured, and the more likely things are to kind of get messed up along the way. We have our little picture here that you can kind of see. This is a simple virtual network that I have set up here in this picture, and you can see the virtual machines with their virtual NICs connected to the virtual switch in the hypervisor, and then that transfers through to the actual physical NIC that's outside of the hypervisor in the physical host. If there were a third VM in the picture, unless it was connected to the same virtual switch, it would also have no way to access any kind of protected item, so it would have to be connected to that virtual switch. It would have to be connected to a virtual switch as well. So we'll talk a little bit more about virtual networking a little later on down the line. We just kind of want to introduce some concepts today. In a few more weeks, we'll look at some more virtual networking related type stuff. Virtual storage. So virtual servers and virtual devices, you need storage to work with. You got to have storage to save files, to save your operating system, to do whatever it is that you're doing. Right? So what gets presented to the virtual machine and what the virtual machine believes it has are two completely different things. So, like as you all know, you can essentially set up your storage basically wherever you want to on your computer. When you've been setting up your virtual machines, you can. Hey Vince, I see your question there. Let me backtrack a little bit so I can answer it. Sorry, I missed it. Using a VPN on a virtual machine. Yes. You would probably still want to use a VPN on a virtual machine if you were connecting it to the network. If you were doing host only networking, it would be like a LAN. So it would just be like essentially like file sharing between hosts and other VMs. So if you were to go onto the internet with your VM, you would probably still want to use a VPN if you were doing things that you think you needed a VPN for. If you were on public services or that sort of thing. Because it would be because it would still be routing the traffic through your. Come to think of it. Yeah, because it'd still be routing the traffic through your physical NIC because your virtual NIC is still virtualized, so it's kind of a. It has a different IP address, but it would still resolve to your physical NIC, and it would still resolve that IP to your local area. So it could still get back to you, but it would be a little. I mean, come to think of it, like it is another layer, so it would be like traveling through another layer on the OSI model. So it would be a little more obfuscated, but I would still recommend running a VPN because it is like another like layer 2 device in the middle there. But yeah, you'd still want a VPN if you were doing something that you think would need a VPN, I would say. But yeah. Anyway, back to virtual storage. So with virtual storage, as you know, when you were setting up your own virtual machines, you can put your storage basically wherever you want to put it. On whatever drive that you have, whatever, if C drive, D drive, E drive, whatever you've got. But that virtual machine is going to see the C drive. Even if where that C drive is actually stored on your host machine is your E drive or whatever it is. Right? So those drives that are on your virtual machine are just carved out of regions of disk space on your shared storage device on that hard drive that you have. That you're just kind of carving that up and taking out chunks and dedicating them to your virtual machines, and in those new virtual machines, they're now C drives. So even though it's actually just a chunk of your host's hard drive, the virtual machine sees it as its C drive. So it sees it as a real physical C drive, even though it's not. It's a virtualized chunk of hardware. And so like our picture here, it's showing a virtual machine that's running Windows. You know, it's got a C drive and a D drive. And it's just kind of showing it being carved out of that space. So let's talk really briefly about how virtual machines work. And this is, you know, in this instance, we're kind of talking about how hypervisors control the resources and kind of traverse between the virtual machine and the host. So one way to look at how virtualization works is to say that, you know, the hypervisor kind of allows the disconnection of traditional operating systems from the hardware. So the hypervisor becomes the transporter and the regulator of resources to and from the virtual guests that it supports, all of the virtual machines that you have on your device. It's sort of the porter that's ushering around all the different resources. So it's basically fooling the guest operating system into believing that the hypervisor is actually the hardware. So the virtual machine operating systems are making normal requests that go through virtual hardware, and the hypervisor is kind of fooling these virtual operating systems into thinking that this virtual hardware is real hardware. And in turn, the hypervisor then controls the physical resources and manages the transaction from the virtual hardware to the physical hardware and on back again. So the hypervisor is kind of doing this dance while it's tricking all these virtual machine operating systems. So when we look at, you know, kind of how virtual machines kind of work in a nutshell, I mean, that's basically what we're looking at. You know, the hypervisor is the go-between that makes things work, and then the virtual machine's operating system is making normal requests because it thinks the hardware that it sees is real, but it's virtualized by the hypervisor, and the hypervisor manages all the resources on the back end. So here we have just a few terms that I wanted to define really quickly. And some of these we've already talked about. Just wanted to mention them again briefly. Clones, which are duplicates that duplicate the virtual hardware and all of the software. Templates, which I don't know that we've mentioned yet, which is a non-running virtual machine that acts as a standardized mold for a new VM. So, you know, if you have a standardized configuration that you like to install things on, that would be a template, which, you know, kind of seems reasonable for the use of the word template. Snapshots, which are a point in time captured state of a VM that can be returned to over and over again, which we do have videos for clones and snapshots, I think, in the current module. I mentioned about how to make clones and snapshots in VirtualBox. So you'll want to have a look at those to kind of back that up. And so these all make virtual machines more agile than physical servers because we're able to kind of take things and duplicate them, take things at a certain point in time and duplicate them, take things and make a template. So we can kind of do things quickly over and over again without having to do a whole bunch of setup or write some kind of fancy script that we run onto a physical server for server configuration. It just makes things quick, makes things easy, makes things efficient. And working with virtual machines, like efficiency is kind of what it boils down to. And finally, I briefly want to look at the open virtualization format, which is a vendor-neutral industry standard. So, being vendor-neutral, it's cross-vendor and cross-platform. So, a lot of different hypervisors will utilize the open virtualization format, and we actually use in this module a .ova file or an open virtual appliance. So I wanted to include this here so you all kind of have a little bit more information about what that is. So the open virtualization format is, we're using this to export and import virtual machines from one platform to another. So you take in and you're bundling the configuration, that whole lump of files that we talked about at the beginning that a virtual machine or virtual appliance is. You take them and you lump them into one singular file that we can kind of import into a hypervisor, and it just kind of spins it up and goes. And so it's designated by a .ova extension, and that stands for Open Virtual Appliance or Open Virtual Application. And in the lab for the current module that you all are in, that's one of the things that you all utilize is you go out and you get an OVA from Turnkey Linux and you install it on a virtual machine. So by learning this, now you know .ova is an open virtualization format file. So that file is vendor neutral, even though we're using it with VirtualBox here. You could also use it with a VMware or any other type of virtualization or virtualized any other type of hypervisor that you might get your hands on. So I believe that's my last slide. Yep, there's my summary. So just to run down my summary real quick, virtual machines are containers that run workloads on top of hypervisors. They are much more flexible than physical servers, which have kind of been like the running theme. From a user or an application standpoint, VMs look and act like physical servers. VMs are incredibly cost-effective. The OVF standard allows cross-platform and cross-vendor distribution and deployment of pre-built applications, and containers are a newer technology similar in function to VMs and still maturing. So I think we talked about containers last week a little bit. So yeah, containers. So that brings us to the 30-minute mark, and I don't like these to go any longer than around 30 minutes. I will turn the music back on, stay a while, stay and answer questions in the chat for a couple minutes if you have them. But that's all that I have for you all today. Thank you for coming, and we'll see you next time.
Forget that you're the reason I'm alive. I'm the one you designed. I'm connected, but I'm not really online. What am I? Where am I? Why you acting like I'm not really alive? Switches on, switches on, switches